So now we're going to continue with the series, namely power series in 11.8. So first, what is a power series and what are the conditions at which the power series converges? What's the radius of convergence? And what's the center of the series, the power series? So an expression of the form C0 plus C1x plus C2x squared. Notice the indices are changing with the exponent. C3x cubed plus Cnxn. It doesn't end here, it keeps going to infinity, which is sigma C n x to the n equals 0 to infinity. Is called a power series. It's called a power series centered at x equals 0. Centered at x equals 0 because you don't have this is Cn x minus 0 to the n. Okay, that's the center. Now we can expand it to any center if it was C0 plus C1 x minus a plus C2 x minus a squared plus Cn x minus a to the n plus, which is sigma Cn x minus a to the n equals 0 to infinity. This is a power series centered at a. Okay, it's a power series centered at a. At x equals a. And of course this is this term as always, and a is the center in this case. So we know of at least one power series, which is this, sigma n equals 0 to infinity x to the n. X to the 0 is 1, x to the 1, x squared, x cubed, and so on. This is a power series, obviously, it takes that form. The constants are all ones though, centered at 0. And we know it converges, it's a geometric series. With common ratio x, so it converges if the common ratio is between -1 and 1, and diverges if x is greater than 1 or less than -1, greater or equal. Okay. Alright, so under what conditions does a power series converge? So convergence theorem for power series. There are three possibilities. For the convergence of the power series. Sigma Cn x minus a to the n equals 0 to infinity. The first one, if there is a positive number r, there is a positive number r such that the series converges for absolute value of x minus a less than r, or x minus a is between -r and r, or a minus r is less than x. These are all equivalent, okay? If absolute value of x minus a is less than r, absolute value of x is less than 1. This is r, okay? So if there's a number r, in this case there's a number 1, such that the series converges for absolute value of x minus a less than r, but diverges for absolute value of x minus a is greater than r. The series may or may not, we don't know, it doesn't have to be either or may or may not converge at the endpoint at x equal a minus r, x equals a plus r. So this could be less or equal, or it doesn't have to, okay? So this is a possibility which we have an example right there. And in this case, r is called the radius of convergence, and in the example above, r is 1. Okay, the radius of convergence is 1, and the center is 0. So that's the first case scenario. The second case scenario is if the series converges unlimited. In other words, for every x, no matter what you put in, for every real number x. In this case, the radius of convergence is infinity. In this case, the radius of convergence r is infinity. Here's an example about that. Sigma n equals 0 to infinity 3x to the n over 2n factorial. This is a power series because we can write this as 3 to the n over 2n factorial x to the n. Okay, so this is Cn x to the n. So this is a power series centered at 0. And to see if it converges, we use, for series, we always use the ratio test. Okay, use ratio test for power series. Okay, so using the ratio test, limit as n goes to infinity, absolute value of an plus 1 over an, which equals limit as n goes to infinity, absolute value 3 to the n plus 1, x to the n plus 1 over 2n plus 2 factorial divided by a to the n, which is 3 to the n, x to the n over 2n factorial. Okay, so which equals limit as n goes to infinity, absolute value of, so we times by the reciprocal, so we have 3 to the n plus 1, x to the n plus 1 over 2n plus 2 factorial times 2n factorial over 3 to the n x to the n. So that gives me an x, and that gives me a 3 up there, 3x. And then 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. So we end up with limit as n goes to infinity, and value of 3x over 2n plus 2 times 2n plus 1. As n goes to infinity, this is 0 for all real values x. Okay. Right, as n goes to infinity, so that means series converges for all x from negative infinity to infinity. This, the radius of convergence is infinity. Okay, the radius of convergence is infinity. So this is the second case, and then you pull about it. The third case, the series converges at just a specific value a and diverges elsewhere. Power series converges at x equals a and diverges elsewhere. In this case, the radius of convergence is 0. Here's an example about this. Sigma n equals 0 to infinity n factorial x to the n. You know, if you try the if you try the ratio test like we did in the previous one over an, this is limit as n goes to infinity n plus 1 factorial x to the n plus 1 over n factorial x to the n. So you get n plus 1 and then n plus 1x, which goes to infinity. So that's just, so if you look at the ratio test, which is an 11.6, if the limit is less than 1, then the series is convergent. If it's greater than 1 or infinity, then the series is divergent. So it diverges. Okay? Because you get infinity, except when x is 0 though, because infinity times 0 is indefinite if x is not 0. Okay? It diverges if x is not 0. Right? It diverges if x is not 0. So for x equals 0, what happens? Sum from n equals 0 to infinity n factorial times 0 to the n, which is 0 factorial times 0 plus 1 factorial times 0 squared plus 0, which equals 0. So for x equals 0, sum of 0 is 0, which converges only for x equals 0. That's x equals a. In this case, the radius of convergence is infinity, and this series diverges elsewhere. Okay. So now we just went over all the three cases. And we're going to see more examples. Okay. Here's more examples. So n equals 0 to infinity, negative 1 to the n, 2 to the n, x. And again, this is c to the x to the n. Check convergence and then radius of convergence and so on. So using the ratio test, limit as n goes to infinity, absolute value an plus 1 over an. This equals limit as n goes to infinity, negative 1 to the n plus 1, x to the n plus 1 over 2 to the n plus 1. Instead of dividing by an, we're going to times by the reciprocal, so we can save some work, which is limit as n goes to infinity of, so we have negative, that we have negative 1, x to the n plus 1 over x to the n is x, and then 2 at the bottom. So absolute value of negative x over 2, which converges if absolute value of negative x over 2 is less than 1, which means absolute value of x is less than 2, or x is between negative and 2. The radius of convergence is 2, and the center is 0. Alright. Here's another example. Sigma n equals 0 to infinity, negative 1 to the n plus 1, n plus 1, x to the n. Again, cn x to the n. So using the ratio test, absolute value an plus 1 over an. Limit as n goes to infinity. So we're gonna do negative 1, n plus 1 is n plus 2, n plus 1 is n plus 2, x to the n plus 1 over this guy, because that's yours, an, n plus 1, x to the n. So we have negative 1, and then x on top. So it's limit as n goes to infinity, negative n plus 2 times x over n plus 1. As n goes to infinity, n plus 2 over n plus 1 is 1. Absolute value of negative x is absolute value of x. So converges if absolute value of x is less than 1. X is between negative 1 and 1. Again, the radius of convergence is 1. Okay. So now what happens at negative 1 and then at 1? Let's check. Okay, what happens at x equals negative 1 and at x equals 1? So this is the series sigma n equals 0 to infinity, negative 1 to the n plus 1, n plus 1, x to the n. So at x equals negative 1, so we're going to get sigma n equals 0 to infinity, negative 1, n plus 1, n plus 1, negative 1 to the n. So that gives me negative 1 to the n to the 2n plus 1, n plus 1. If you use the nth theorem test for divergence, the limit as n goes to infinity of an, it's going to be infinity is not 0, so it diverges. And same thing at 1. If you put a 1, same thing, okay? You get 1 to the n, that's going to give you infinity, so it diverges. So it converges only from negative 1 to 1 and diverges elsewhere. All right. What about sigma n equals 0 to infinity, negative 1 to the n, n factorial over 3 to the n. So this is centered at x equals 4, okay? And all this is Cn, x minus a to the n. You can see why it's a power series. So if you're using the ratio test to decide convergence, absolute value of an plus 1, negative 1 to the n plus 1, n plus 1 factorial, x minus 4 to the n plus 1, over 3 to the n plus 1 times the reciprocal of an, so it'd be 3 to the n, negative 1 to the n, n factorial, x minus 4 to the n. So we get negative 1, n plus 1 factorial over n factorial is n plus 1, and you get here x minus 4, and that's going to give me 3 at the bottom. So the limit as n goes to infinity, absolute value of negative n plus 1, x minus 4 over 3. So this goes to infinity, obviously, except when x plus minus 4 equals 0, because it will be a determinant. Infinity times 0 is a determinant, except when x minus 4 equals 0, when x equals 4. Okay, so r equals 0, obviously, right? Because when x equals 4, series converges. This is the case where it converges only at one value. Okay, remember we have 3 cases. If you put a 4 in here, so you get 0 plus 0, 0 plus 0. So it converges there and diverges everywhere else. The last case where it converges at a single point. Most of them converge for an interval, but you know, there's exceptions, of course. All right, last example. Let's check sigma n equals 0 to infinity, negative 1 to the n, x to the 2n 1, and you can see I'm always using the ratio test. So the limit as n goes to infinity, absolute value an plus 1, where an is limit as n goes to infinity, so negative 1 to the n plus 1, x to the 2n plus 2 plus 1, 2n plus 3, over 2n plus 2, 1, 2n plus 3 times the reciprocal, negative 1 to the n, x to the 2n plus 1. So that's going to leave me with negative 1. That's going to leave me with x squared and 2n plus 1 over 2n plus 3. So limit as n goes to infinity, absolute value negative 1, 2n plus 1, 2n plus 3, x squared. Okay. Which converges if absolute value of x squared less than 1, which is a, why is that? Because when you do n goes to infinity, you get absolute value of negative x squared, which is x squared, right? X squared is always positive. Negative 2 over 2 is negative 1, but the absolute value is going to give you the positive x squared. And we know the ratio test. If this limit is less than 1, it converges, so x has to be between negative 1 and 1. So what about at the end point? What about at x equal negative 1? We always have to check those if we have an interval, okay? So at negative 1, we get sigma negative 1 to the n, negative 1 to the 2n plus 1, over 2 plus 1. I plugged it into the original, which is negative 1 to the n plus 2n plus 1, 3n 1 over 2n plus 1. This converges by the alternating series test. Same at x equal 1. Okay, check that out. It converges. So the series converges on negative 1, 1. The radius is 1, and the center is 0. And that's it for the power series. Okay. 11.8. We'll see you in 11.9 soon.